Okay, so today we are going to do the review for test number 2. Okay, hopefully we'll be able to get through all of it. There are 25 questions, and remember, when you do the test review, you can do it as many times as you want. The gradebook is only going to record the very highest score that you get. And also that you'll notice when you took test number 1, how similar it was to the test review. The same thing's going to happen with this test. Okay. The more that you take that test review, the better chance you have of doing well on the actual test. Okay. Let's look at number 1. Determine visually whether the function is even, odd, or neither. And here's what the function looks like on the graph. Okay, when it's talking about even and odd symmetry, we're talking about the symmetrical characteristics of the graph. Okay, if you are symmetrical with the y-axis, you are an even function. Okay, odd functions come into play when you are symmetrical with the origin. That makes you an odd function, which means you would be symmetrical with the origin, which is right here. This one's going to go along with that top one though, right? Look at this. What axis, if you folded it along this y-axis, wouldn't this side lay on this side? Or in other words, this side, the left side of the y-axis, is the exact mirror image of the right side, which means this graph is symmetrical with the y-axis, which means that is an even function. All right, numbers 2, 3, and 4 are going to go along with those transformation rules that we talked about in 7.2, where you have the inside numbers are going to shift you left and right, but you're going to go opposite the sign, right? So a plus is actually going to shift you to the left, and a minus will shift you to the right. The outside numbers shift you up and down, and you do go with that sign. So a plus shifts you up and a minus shifts you down. Okay, so let's look at some of these, starting with number 2. G of x equals x plus 1 squared plus 4. Okay, so first of all, it's going to ask you, what shape are you going to be? What is the shape of this graph going to start off with? What's going to give it its shape? It's going to start off with the graph of x squared. That's what's giving it the U shape. Then we're going to talk about where are the shifts going to occur. This number right here, what is inside the parentheses, shifts you left or right, but you go opposite the sign. So this plus 1 is going to shift you to the left 1. The outside numbers shift you up and down, and you go with that sign. So that is going to shift you up 4. Now, on this particular problem, after you tell it what shape it's going to be, the horizontal shift and the vertical shift, then it's going to ask you to graph this. Now, this is the one section where when you're graphing, remember over here in your toolbox, you're going to choose that U shape to tell it you want it to graph a parabola. And on this particular problem, you're going to click anywhere in this coordinate plane right here And it's actually going to put a U shape right there at the middle, at the origin, with its vertex at the origin. And then it's going to give you the box down here where you tell it to do these two things. You want to shift it to the left 1 and up 4. And when you do that, it actually shifts this parabola's vertex to the left 1 and up 4 for you. Okay, it's not asking you to plot a bunch of points on that parabola. It's asking you to just do the shifting down here in that shifting box. All right, number 3 is another shifting problem. It's the square root shape, but they all follow the same shifting rules. This one's f of x equals the square root of x minus 10. So let's see, this is an inside number, right? It's inside the square root symbol. It's not outside of it, out over here. So that is going to be a horizontal shift. I'm going to go opposite the way this sign is telling me. So this one is actually shifting me to the right 10. And then you'll notice all the A, B, C, and D, they're all the same shape. It's just that one's shifted down. There's the one shifted to the right, to the left, and up. Okay, so make sure that you would just choose the graph that has been shifted to the right 10. Number 4, another shifting problem. G of x equals, this one has a negative in front of the parentheses, x minus 2 squared plus 5. So let's see, the first thing it's going to ask you is, it's going to start off with x squared, then it's going to talk about the horizontal shift. Or the horizontal shift is on the inside. So that minus 2 will shift you to the right 2. Then it's going to say, okay, what is this telling me to do? Am I reflecting across the x-axis or the y-axis? This negative is going to turn that parabola upside down, or in other words, it's going to reflect the parabola across the x-axis. And then the last thing it's going to talk about is this vertical shifting number, the number on the outside. So outside numbers shift you up and down. You go with that sign. So I'm going to shift up 5. All right, the next 2 problems are both, if you have gotten the quad program in your calculator, then you're just going straight to quad. If not, you're going to need to go back to the 7.4 video and look at how to do these problems by hand. Okay, numbers 5 says find the zeros of the following functions. F of a equals a squared plus 12a plus 32. So if I have the quad program, I'm just going to need to know what are my A, B, and C. And how do you know this is a quad program problem? Because it's a squared problem. If you are solving an equation for somebody that's squared, then that's what's telling you I can go to my quad program for that. So A is going to be what's in front of your squared term. Your B is going to be what's in front of, in this case, in front of the A. Your C is your constant, which is your number that doesn't have a variable on it. So let's see, my A, what's in front of A squared here? I just don't see it, which means it's a 1. My B is the number in front of this term, so it's positive 12. My C is my constant, which is 32. So once I know those A, B, and C, that's when I'm going to my quad program. So hit your program button and go down to quad. And hit enter. And hit enter again. So it's going to ask you, what's your A? Well, my A is positive 1. Enter. My B is positive 12. Enter. And my C is positive 32. Enter. So my solutions to this, or my zeros to this problem, are -4 and -8. Okay. Now that is not a point. You do not put that in parentheses. When you put somebody in parentheses, you are saying this is a point on a graph, right? That's not a point on a graph. That's just, if I plugged in either one of the -4 or the 8 in for those A's, that's going to make that solution true if I put it equal to 0. Okay, same thing's happening on number 6. F of x equals 5x squared minus x plus 8. So this one, same numbers are A, B, and C in front of your squared term. There's your A. In front of your X, there's your B. Your constant is C. So in front of the squared term, my A is 5. My B is the number that's in front of this X. I have just a minus sign, which means it's a -1. And then C is my constant, which is positive 8. You can put that in your quad. So if you still have your numbers in there from the last quad, just hit enter and enter again, and it just takes you right back. So my A is 5. My B is -1, and my C is positive 8. Hit enter. There are your 2 solutions, right? Just like the last one had 2 solutions, this one has 2 solutions also. Now, remember, when you are typing this in, though, you notice that these are the exact same. It's just that one's a plus and one's a minus. So remember, MathLab will let you type that all in together. You will just tell it that you want it to be a fraction, to give it the fraction bar. And then you would hit the 1. Then also down here in the toolbox, there's a plus-minus button, which takes care of the +1 and the -1. And then just hit your I. You can use the I from the keyboard, or I think there's one down there in the toolbox. Square root of 159 over 10. Right? Number 7. All right, 7 gives me another picture of a parabola, and it tells me this parabola goes with the function or the equation x squared minus 4x minus 5 equals 0. It shows me what it would look like if I put this function in my y equals and graphed it. That it would cross through the x-axis at -1 and +5. The first thing it's going to ask me me, it's just trying to get you to be familiar with the relationship between the x-intercepts of a parabola and what the solutions are if you put that in your quad. Okay, so the x-intercepts are the 2 points where it crosses the x-axis. I'm typing in physical points. All points are ordered pairs. The x-coordinate is going to be the x at where it crosses through the x-axis. So this one's at -1. The y-coordinate of any x-intercept is always 0, right? Because what does that mean? If your y is 0, that means your point hasn't gone up or down at all. That's what makes it still be on the x-axis. So my y-coordinate is 0 on that one. This one, other one crosses through at +5. And again, its y-coordinate is 0. So how does this relate to what the solutions are to this quad equation? Well, the solutions, if I went to quad and put this A, B, and C in, it's going to tell me my solutions are -1 and 5. This is not in parentheses though, right? This is not a point. These are the solutions to this equation. They're just related to where this crosses through the x-axis. So x-intercepts are points. Solutions are just the x-coordinates of those points. All right, number 8 and number 9. Number 8 and number 9 are both dealing with right triangles. And you'll see once you draw out what the paragraph is talking about. So before we get into these problems, let's just remind ourselves of the Pythagorean theorem that goes with all right triangles. Which means the length of one side squared plus the length of the other side squared is going to be the same as the length of this side, which has to be your C, squared. So let's read number 8. A wire is stretched from the ground to the top of an antenna tower. So here's my wire. It's stretched from the ground to the top of a tower. So here's my wire. Here's my tower. It says the wire is 35 feet long. So it tells me how long the wire is. Then it says the height of the tower, so here's my tower, its height is 7 feet longer or greater than the distance from the tower's base to the end of the wire. So in other words, this side here is 7 feet longer than this side here. So let's see, if this side is my X and this side's 7 feet longer than that, that just means it's X plus 7 more. So now let's use this information that we have from what they've told us and plug it into our Pythagorean theorem, which is this side squared. So this side is X plus 7 squared plus this side, which is just my X, and I got to square it too, right? This side squared plus this side squared is equal to the diagonal, which is the hypotenuse, and this one is 35 squared. So let's see. This right side is not too bad to figure out. 35 squared just means 35 times 35, which gives me 1225. Over here, I got a little bit more work to do. X plus 7 squared. What does that mean? That means x plus 7 times itself. So I'm going to have to FOIL that. Right? So my first x times x gives me x squared. My adder, x times positive 7 is 7x. My inner, another 7 times x, which is 7x. And then my last 7 times 7 is positive 49. So let's see what we have here. I can put these x's together. So now I have x squared plus 14x plus 49. So that's what this is, right? The x plus 7 squared that we worked over there ended up being x squared plus 14x plus 49. Now just drop down this plus x squared. So remember what we were saying about solving equations. Anytime you're solving an equation and you notice, okay, it's not just x, but it's an x squared equation. That is when you're going to be able to go to your quad program to solve it. Okay, so knowing that this translates into a quad program problem tells me that's what I want to use. So here, in order to do that, you're going to have to know what your A, B, and C are, right? Because that's what the quad program asks you. What is your A, what is your B, and what is your C? So I've got to clean this up because I got too many terms and I got terms on both sides. So before I do anything else, I want to put this x squared and this x squared together. So I've got 2x squareds here plus 14x plus 49 equals 1225. Now, again, trying to get down to where I can see my A, B, and C. I need that my C is my constant, right? I've got two constants. I have two numbers that don't have variables hooked on them. That's the reason why all your terms need to be on one side together. So I need to move this 1225 over here by getting rid of it on the right side. I'm going to subtract 1225 from both sides. So that side's going to be 0, which is what I want. You need all three terms over here set equal to 0. So here I've got 2x squared plus 14x, and now I've got 49 minus 1225. So if I subtract that, I get negative 1176. So now I know my A, B, and C for my quad. My A is in front of the x squared, it's 2. My B is in front of x, so it's 14. C is my constant, which now I just have one constant because I put them all together, is negative 1176. So let's put that in our quad program. So just hit enter again. What's your A? Your A, where'd it go? Is 2. Your B is 14. And your C was negative 1176. Uh-oh. Sorry. So 2, 14, and negative 1176. Hit enter. There. Now remember, it's a quad solution, so there's a good chance I'm going to get two answers, 21 and negative 28. So let's remember what X represents. What does X represent? X represents this distance right here, right? That's my X. Well, if I'm talking about the distance from the base of the tower to where the wire connects here, I cannot be talking about a negative number, right? That distance cannot be. So 28, or excuse me, negative 28 cannot be what that solution is. So I'm using this positive 21 as my X. Then this side is represented by whatever my X is, which now I know is 21. add 7 to it. So this side will be 28. So when you're answering the problem, the first question says the distance from the wire to the tower. So from the wire to the tower is 21. And then the height of the tower is that 28. Okay, number 8. I mean, number 9, that was number 8. Looks like it's going to start off the same. Because it says the foot of an extension ladder is 9 feet from the wall. So here's my ladder. And here's the wall that it's leaning up against. The foot of the ladder is 9 feet from the wall. So this side is 9. Then it says the height that the ladder reaches on the wall, so this height right here, and the length of the ladder are what's called consecutive integers. Consecutive integers just means that one number comes directly after the other. So this number, the length of the ladder, comes right after this number. So if I don't know what either one of them are, so I'm just going to say that one's X. And if this one comes right after that, I just need to add 1 to it. So now let's set this one up according to this Pythagorean theorem to see if I can find its X. So I need this side and square it. So X squared plus this side, which is 9, and square it, equals the hypotenuse, which is the other side, the diagonal side, which in this case is X plus 1, and square it. So let's see what we have here. On the left, I've got the X squared plus 9 squared, which is 81. Now, on the right, I've got X plus 1 squared, so I need to FOIL here again. Right? Because the X plus 1 squared means to multiply the X plus 1 times itself. So if I FOIL here, X times X gives me X squared. My outside, X times positive 1 is 1X. My inside, positive 1 times X is another positive 1X. And then my last, 1 times 1 is 1. What do you get when you put these X's together? You actually have 1 plus 1, so you have 2 X's. So you've got X squared plus 2X plus 1 on the right side. So once again, I noticed that the X I'm solving for is an X squared equation, which means all my terms need to be on one side and set equal to 0. But what happens during that process? I need my X squareds to be together, which means I need to subtract it off of this side to put it on the other. But when I subtracted the X squared here, I had to do it to the left. And what happened is it actually canceled it off of both sides, which means I don't have an X squared anymore. So let's see what I have left. I've got the 81 on this side equals 2X plus 1 on this side. So this is just a plain get the x by itself, right? I don't have squareds anymore. So if I need to get this x by itself, I need to subtract 1. So 81 minus 1 gives me 80 equals 2x. Divide by 2 on both sides. So now I know that x equals 40. Now let's be careful. What is represented by the x? Let's come back up to our triangle. Here's my x. So it's 40. Which means if I add 1 to that or make it the next number, it's going to be 41. The only question that the problem asks of you is what is the length of the ladder? That's this side, right? So the answer to that is 41. The ladder is 41 feet. All right. Number 10. All right. Getting to number 10, this is getting to the sections where we were talking a lot about the vertex of a parabola, which is the point at where it changes direction. And it gives us a lot of information about the rest of the parabola also. All right, it shows us this graph. It actually even says, here's your parabola, here's its vertex, and it tells you the vertex is at 3, 0. It gives you all of that information in the picture of the graph. And then the first question it asks you is, what is the vertex? Well, I can just look over there. It told me that the vertex was at 3, 0. What this problem is trying to get across is other information that you can get from knowing what the vertex is. The next thing it asks you is, what is the axis of symmetry? Well, what is axis just means line. What is the line of symmetry? The line of symmetry is the vertical line that goes straight through the vertex. Now, in math lab, it actually even says, make sure you type in an equation because a line always comes from an equation. So let's see, every single point on this line, doesn't matter where you are, the x coordinate is going to be the same as the x coordinate of this vertex, right? This line, if you are on that vertical line, that means your point is to the right 3, which means x equals 3. So every time you know what the vertex is, you actually also know what the axis of symmetry is. It's just going to be the equation x equals whatever the x coordinate was. You're also going to know what the value of that vertex is. Now, this one, if your vertex is at the bottom of your parabola, like this one, that means it's going to have a minimum value. There is going to be a bottom to that vertex or to that parabola. Okay, so this one's going to have a minimum value. The minimum or maximum, the value is always talking about the y coordinate of the vertex. Okay, it is not an equation. It is not talking about a line. It is just talking about the lowest y number, which is 0 in this situation. All right, number 11. All right, this one is going to ask me some of the same stuff, but it's not going to give me the picture with the vertex written out. It's going to give me the equation of this function and ask me to still find all this same stuff. So f of x equals 2x squared plus 6x plus 2. And still, the first question it's going to ask me about this parabola, since it's an x squared graph, it's going to make a parabola, is what's its vertex? So let's go to our y equals on our graph and clear it out. Type in this function. So 2x squared plus 6x plus 2. So 2 and your x and your squared plus 6x plus 2. And then graph it. So here's my parabola. Now I can find the vertex, right? This vertex is this point right here. So when it's a regular parabola and you're asked to find the vertex, you're finding the minimum, right? The bottom number down here. So let's tell it that. We want to find the minimum by hitting our second button and then calc right here. It's the trace button. It's going to give us a lot of options. I want to find the minimum, right? Since the vertex is the bottom point. Now it's going to ask me two things. What it's wanting me to do is have my cursor be on the left side, and then it wants me to move it over to the right. So as of right now, it's blinking right here. I need to move it to the left side because it's asking me, is your cursor on the left? No, it's not. It's on the right. I need to move it over there. So just move it, and you can put it anywhere on the left side and hit enter. Now it's saying, okay, I need it to be on the right. So now you're going to do the same thing. You're going to move it with your right arrow back over to the right side. Anywhere. And hit enter twice. That's going to be your vertex. This one has decimals. So we are going to run into an issue, but let's write this down. This one's vertex is at negative 1.5, negative 2.5. So negative 1.5, 2.5. Okay, so I am going to have to turn those into fractions. Oh, I think this is negative 2, isn't it? I lost it since my batteries fell out. I am going to have to turn those into fractions, but you can do that on just your plain home screen by just typing in what the decimal you're wanting to turn in. So negative 1.5. Now just hit your math button and then hit the enter button twice, because what that's going to do, it's going to turn your decimal into a fraction. So that's going to be negative 3/2. If you do it again with this one, it'll be negative 5/2. Okay, so that's going to be my vertex, and this is how you're going to have to type it into MATLAB using the fractions. But now that I have that, it's wanting to know what is the axis of symmetry. Which is always x equals, and then just type in what the x coordinate of the vertex was. So x equals negative 3/2. Okay, Then it wants to know, does this parabola have a maximum or a minimum? Now remember, it was like this. It wasn't upside down. So this point right here, its vertex was at the bottom, which means it has its minimum. And what was the minimum value? The value is always your y coordinate. So -5. Right, number 12 is a true-false problem. And again, it's going along with my shifting rules. It says the graph of h of x equals x plus 1 squared can be obtained by translating the graph of x squared to the right 1 unit. So let's think about that. Would this shift it to the right 1? Here's my shift. It is a horizontal shift, but +1, I go opposite the sign. So that is false because I actually would shift this to the left 1. Right? Number 13. All right, same kind of problem. It's just going to ask more information about this one. F of x equals x squared minus 10x plus 16. And again, it's going to start off by asking me the vertex. So again, I'm going to go to my y equals and clear it out and put in this new function. So x squared minus 10x plus 16. Let's graph it. So here's my vertex. Again, it's the minimum of the parabola, right? Because it's at the very bottom. So when I want to find the vertex, that's what I'm going to tell it. I'm going to say I need to find this minimum point down here. So second calc down to minimum. Then it's going to say, okay, is your cursor on the left? Okay, I don't even see my cursor, but this always tells you where your cursor is. It's at 0, 16, which means it's on the y-axis at 16. So it's about right here. So is that on the left side of the parabola? It is. I just can't see it. If you're nervous about that, just take it, use your right arrow to move it down until you can see it to make sure. There it is. It's on the left side of the parabola. So hit enter. And then keep making it go to the right to put it on the right side of the parabola. All right, so there it is on the right. So hit enter and enter again. Remember that last one, you always hit enter twice. So this one's parabola is at 5, -9. I mean, not its parabola, it's vertex. So let's see. So over to the right 5, down 9. So we're going to say it's right here. The next thing it wants to know is whether or not the parabola opens upward and has a minimum, or does it open downward and have a maximum, right? This one opens up and has a minimum. And it wants to know, what is the minimum value? Well, remember what the minimum value is. It's just whatever that x coordinate was. So its minimum value is -9. Now, here's the new thing that this problem is asking you is, what is the range of this parabola? The range of it is, what are all the y values in this graph? Well, what you just said in the part right before this is that the minimum, or in other words, the very lowest y value, or in other words, where the y values start is -9. Then they go up from there, right? Because if this is 5, -9, that's this lowest y. The y values just go up from there. So the range starts at -9, and I do put a bracket around that -9 because -9 is included in the range. Now, what do the y values go to? They go up forever. There's no stopping there. So they go to infinity. So you'll use a parenthesis. All right, the last two parts I want to know, where is this parabola increasing and decreasing? So let's look at the left side. What are the values doing on the left side? They are going down, which means this side, the values are decreasing until they get to this point, until they get to that vertex. And then on this side, they start to go up. So they increase. Okay, so if that's the case, let's talk about the increase. Now, when you're talking about increasing and decreasing, you're still using the vertex number, but you're using the x coordinate. So I start, here's my increase side. This is where I start increasing at 5. Okay, I start my increase at 5, and then I increase forever to infinity. The decrease is this side. I stop my decrease at 5, right? 5 is where the decrease stops and does what? Changes to increase. So where do you start decreasing then? All the way from the left side of the graph, which is -infinity. Now, when you're talking about increasing and decreasing, two things. You're always using the x coordinate of the point, and you're always using parentheses around both of them. All right, number 14. Same kind of problem, but this time it's -4x squared minus 4x plus 1. Okay, it's asking me the same questions. The first thing it's going to ask me is the vertex. So once again, I'm going to go to my y equals and clear it out. So y equals, clear it out and put in my new function here. Now this one does have a negative in front of it, which is going to do what to the parabola? It's going to shift, it's going to flip it upside down. So -4x squared minus 4x minus 4x plus 1. So plus 1. Now, look at when we graph it. There it is, upside down. So when this time, when we're finding the vertex, we're finding the top of the parabola, right? Which means we need to find its maximum this time. So I'm going to hit second calc. And this time I'm going down to maximum. So let's see, it wants to know where my cursor is. Is it on the left side? I see it blinking right there. So I need to move it over to the left side. So I'll just hit my left button until I see my cursor move over to the left side. Then hit enter and use my right button to move it over to the right. And then hit enter twice. So this one's vertex is at negative 0.52. So, and when I type this into MATLAB, I need to type it in as 0.5 is a half. So negative 1/2, 2 is where the vertex is. Now, this one was upside down with its vertex at the top. So this one opened downwards and had a maximum value of 2, right? The y coordinate is your maximum value. Now it wants to know what is the range of this one. Now remember, the range is your y values. Now this one's different than the last one. My last one was a regular parabola. It wasn't upside down. It had a minimum, which means the range started at the bottom and went up forever. But look, this one has a maximum. So y is actually its very top, 2 is its very top y. All the other y values are below it. So this range starts at negative infinity and goes up to the 2. All right, then the increase and decrease on this one. When your parabola is upside down, this side is the increase, right? Because the values are going up over here. So there's my increase until they get to this point. Once they get to that point, they go down on the other side. So where is this one starting to increase? It starts way over here on the left at negative infinity until it gets to this point. Now remember, when you're talking increase and decrease, you use the x coordinate of this vertex. So it increases until it gets to negative 1/2. And negative 1/2 is also where it does what? Where it starts to go down. So that's where the decrease starts, and it decreases all the way to the right forever. So to infinity. All right, number 15. A toy rocket. This is the rocket ship problem. So let's think about when you shoot off a toy rocket, what does it do? It makes this shape, right? It's going to go up, 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 and then eventually it's going to get to a point and go down. So this is what the toy rocket is doing, okay? It gives me the function that it wants me to use for this toy rocket. The function it uses is negative h of t is negative 16t squared plus 112t plus 4. So again, when you shoot this rocket off, it's going to go until it gets to a maximum point, and then it's going to turn around and go down. So let's put this in our y equals and see if we can find out what that maximum point is, okay? Because when we do, the t, which is the x, is going to be the number of seconds it takes to get to that point. Then the y value of this vertex is going to be the maximum value, right? The highest that the rocket is going to go. So let's come to our y equals. And we'll just put in x's instead of t's. So negative 16x squared plus 112x plus 4. Now, uh-oh, that's not squared. Hang on. There. So negative 16x squared plus 112x plus 4. So now let's graph it. So it's going to make an upside down parabola. So I don't even see the top. I don't have to. I saw that when it was drawing it, it was going up, 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 up. And then at some point it must have got to a top because then it shot down here. So I want to figure out what is that top point. So I'm going to say second calc maximum. Okay, so let's see. There's my cursor. It is on the left side of the parabola. So I'm going to go ahead and hit enter. Now it wants to know if it's on the right. So I'm going to hit this right. The way you can tell whether or not it's passed through that very top point is by your y coordinate. Once it starts going, see how it's going up? Once it starts going down, that means you've passed through your maximum. So it's still going up, 105, 120, 135, 148, 169, 178, 185. It's still going up, 191, 195, 198, 199. It's just still going up just a little bit. Okay, now the y values are going down, which means even though I don't see my cursor over here, I know that I have passed through that maximum. So I can go ahead and hit the enter button twice. So here's what the vertex is, 3.5, 200. Which means it took 3.5 seconds to reach the maximum height of 200. Okay, number 16. Determine the domain of this function. So we're moving on to something new. It's a radical, it's a square root function. So I want to know the domain of this. So remember, when you're dealing with square roots, what's underneath here has to be positive. If not, you're going to get an error message in your calculator. So this right here, whatever is underneath it, which in this case is 4x minus 7, needs to be positive. How do I say that mathematically? Well, it's going to need to be greater than or equal to 0. And then solve it for that x. So add the 7 to both sides. So 4x is greater than or equal to 7. And then divide by 4. So x needs to be greater than or equal to 7/4. All right, number 8, 17. F of x equals the square root of x minus 7, and it wants you to graph it. Actually, it just wants you to choose the multiple choice that is correct. Okay, if you wanted to, you can put that in your y equals, or you could just use your shifting rule. It's going to be a square root graph. Move to the right 7. Here's what you got to be careful about on this one. If I go to y equals and type this in, right? Here is my square root. So I just need to hit the second button, square root. And then under the square root, type in the x minus 7. And let's graph it. All right, so there is my square root graph, and look, it's moved to the right 7. So when you are looking at your multiple choices, what you need to realize is that each hash mark is 5, right? Because look, if that's 20, and it's only taken me 4 hash marks to get there, that means this is 5, 10, 15, 20. So this one has been moved to the right 7, right? Because that's a 5. And it's been moved a little past it. So be careful on that one. Just remember what your hash marks are. All right, number 18 is another square root graph. This one's very difficult to pick out. G of x is the square root of 8x minus 1. When I go put this in to my y equals. So just clear out the old one. Go back to square root. So second square root, 8x minus 1. And graph it. Now, what is hard to see on this is that this graph starts just a little bit to the right side of the origin. And the reason I know that is because the domain of this, what's underneath has to be positive. So when I solve that, I say, okay, 8x has to be greater than or equal to 1, and then divide both sides by 8. So my x's have to be not equal to, greater than or equal to positive 1/8. If you'll notice, when you go to your table, by hitting second table, look what happens when you go to 0. It's error, 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 right? Because this graph doesn't go to the left side or into the x's being negative. So when you are looking at this, it's very hard to tell. A and C were easy to knock out, right? Because they aren't the right shape. But look at B and D. Is it B and D? Yeah. They look very similar. If you blew this one up with the magnifying glass in Math Lab, you'll see that this one actually does start a little bit to the left, which means the x's are in the negative. So that's why it can't be that one and has to be that one. I would definitely use magnifying glasses on that. I mean, the magnifying glass that's in Math Lab by each one of those graphs. All right, number 19. Now we're getting into those piecewise functions. Where we had to see what piece our x was going into. So this one says f of x equals x squared when x is less than -2, x minus 2 for when -2 is less than or equal to x, which is less than or equal to 4. And it's 5x for when x is greater than or equal to 4. So there's 3 parts to this graph, depending on what the x is. So it tells you what the x is right here. So f of -2. Means I need to see where -2 falls in these pieces. So let's see, I see it actually in 2 spots. This top one says when x is less than -2. X is not less than -2, x is -2, which is why we want to use this one, because it has the equal to bar to show me x equals 2, which means this is the part where I would plug into. This one's just a multiple choice question asking you which piece would I plug this -2 into. I would plug it into that x minus 2. All right, number 20. Is the graph of a piecewise function, and it's asking it what intervals is it increasing, decreasing, and constant. Okay, so let's remember what we did on these. Before I did anything else, I went through and labeled what was happening in each piece, whether it was increasing, decreasing, or constant. So this first point right here, the values are going up. So this little interval, that's an increase. Once it gets to this point, it started going down, so that was a decrease. The straight across part is a constant. And then it starts going up again for this little interval. So there's another increase until it gets to this point and it goes straight across again. So that's a constant. So I go through and label each one, whether it's increasing, decreasing, or constant. Then after that, I would go to each one of these points and write its x coordinate so that I don't confuse myself when I'm doing my interval notation and start using y's. So I really don't care what the y coordinates are. I just care about what the x's are. So let's see, where does this first change of direction occur? 1, 2, 3, 4, 5, 6, 7. So it occurs when x is -7. Then here's another change of direction. 1, 2, 3. It's lined up on the x-axis with -5. Then it goes to here. This one's lined up on the x-axis with -2. And then the last one, it's lined up on the x-axis with -1. So let's see, the first thing it says is which intervals is it increasing? So now that I have all that written out, I can just use those numbers. I have 2 increases, right? This is an increase and this is an increase. So this one starts all the way to the left, so -infinity until it gets to this point. And I've already written the number I need from it, which is -7. And the other increase is this interval right here. So it starts to increase at -2, and it increases until it gets to -1. All right, decrease. There's only one area where it goes down from this point to this point. So what is its interval? -7 to -5. And the last question says, okay, where is it constant? And it's constant in 2 places, right? There's a constant, and then there's a constant. This one, its interval, again, I already wrote the numbers down. That's why I do it ahead of time. -5 to -2. And the other constant starts here at -1. and goes to the right forever. So from -1 to infinity. All right, 21. All right, gives me a shape of a parabola, and it's upside down. And it actually tells me what the vertex is. It says, okay, here's your parabola, and I'm even going to tell you what the vertex is. It's 2.5. And then 5.25. So does this one have a maximum? Is its vertex its maximum or its minimum? It's at the top, which means it's its maximum. It says the relative maximum occurs at x equals blank and has value blank. So let's see, it actually even tells you, okay, what's the x? at the maximum. It occurs at 2.5. Value always means y. So 5.25. And then the last thing it wants from this one is, where is it increasing and decreasing? So looking at this graph, the values on the left side of it are going up. So that's going to be the increased side until it gets to this point, and then they start going back down. So here's my decreased side. Now remember, when you're talking increase and decrease, you're always using the x coordinate of the vertex, and everybody has parentheses. So where does this one start its increase? It starts it all the way over here to the left until it gets to this point. So it increases until it gets from negative infinity until it gets to 2.5, which is the same spot. It does what? It starts its decrease. So it starts to go down at 2.5 and it goes down forever to infinity. All right, we are going to go a little bit over, but just for the sake of putting this all in one video, I'm just going to keep going until I finish it. All right, number 22. Okay, it tells me, it's asking me where the relative maximum and the relative minimum is. Even though I just drew this quick, it tells you in the problem where this point is. It says that one's at -8, -1, and it tells you this point is at -2, -19. Okay, so here's my maximum. And let's see, what is the maximum value? The maximum value is -1, and it's at x equals, that's where your -8 goes. And its minimum value, what's the smallest y in the relative minimum, is -19. And it occurs at x equals -2. And it wants to know the increase and decrease. So again, let's label it. Where am I going up? My values are going up until I get to this point. So there's an increase. Then between this point and this point is where the values are going down. So that's the decreasing part of the function. Then once it hits this point, it goes up again. So there's actually another increase. So it's increasing in 2 spots. So where does this one start its increase? Down here at -infinity until it gets to -8. Then it goes down, and then it starts another increase. So, and where's the other one? It starts at -2 and goes forever to the right, so to positive infinity. And then there's only one little spot where it decreases on this interval right here. So it decreases from this x to this x. So from -8 to -2. All right, 3 more. All right, number 23 gives me a piecewise function and asks me to plug in 4 different numbers to it into the correct piece. All right, so h of x is negative 2x minus 17 for when x is less than negative 7. It's just plain old 3 for when negative 7 is less than or equal to x, which is less than 3. And it's x plus 7 for when x is greater than or equal to 3. So let's think about this on a number line. And I'm just going to use the only numbers I see represented are negative 7 and positive 3. When x is less than negative 7, that means all the numbers to the left are below negative 7. This piece represents when x is between negative 7 and 3, which would be just the numbers in between there. This last piece says when x is greater than 3, which means on the right side or bigger than 3. It's going to give me 4 numbers to use. The first one I'm doing is h of negative 9. What that means is, where is negative 9 on this number line? It would be right here, wouldn't it? It'd be less than negative 7. Right? Negative 9 is below negative 7 on the number line. So it's in that top first piece, which is what? Negative 2x minus 17. Now, here's the one extra step you do now. Now I know which piece it goes into. Put it in that x. So if I do that, I'll have negative 2 times negative 9 minus 17. And then do the math. Negative 2 times negative 9 is positive 18 minus 17 is 1. Now it wants me to do the same thing. It wants me to find h of positive 1 this time. So where does 1 fall on this number line? Well, there's negative 7. There's 3, 2, 1 would be right there, which means it's in between the negative 7 and 3. Which piece is that? When is the x between those two numbers? I don't even have any math to do. My answer is always 3. If you are in between these, look, it just says, oh, you're just 3. You don't even have an x to plug into. And I'm going to find h of 3. So where does 3 fall on this number line? Okay, that is one of the numbers represented, which means it's going to actually be showing in 2 pieces, which means that's when you look for the equal to bar, right? I don't want to know when x is less than 3. I want to know when it equals 3, which means it goes in the bottom piece. So x plus 7. Oh, no, don't put it in the 7. Put it in the x. So I'm putting 3 in the x spot. So I have 3 plus 7, which is 10. And then the last one, it wants me to find h of 7. Well, 7 is greater than 3, right? It'd be over here. So it also goes in the x plus 7 spot. I'll put its in place of the x. So now I have 7 plus 7, which is 14. All right, 2 more. The last 2 are the difference quotient problems. Okay, now remember what the difference quotient is. The difference quotient f of x plus h minus f of x all over h. And the first function it wants me to do this for is negative 8x plus 5. Now, on this one, negative 8x plus 5, the first part of the difference quotient says, okay, go to your function. Here's my function. And wherever you see an x, put an x plus 5. So if I do that, I'll have negative 8. Instead of that x, I'll have x plus, what did I say? X plus h. Bring down my plus 5. So again, wherever you see an x, you're going to replace it with x plus h. That takes care of the first part. Then minus, in parentheses, you write exactly what your function is. So negative 8x plus 5. Now, before we deal with the denominator, it's just an h. So I'm going to clean up this top first. I'm going to distribute this negative 8. So negative 8 times x gives me negative 8x. Negative 8 times h gives me negative 8h. Bring down my plus 5. Now, remember, when you distribute this negative to that last parentheses, it's just going to change these signs. It's going to turn that into a positive 8x, and it's going to turn this into a negative 5. And also, everything that you just distributed a negative to should now cancel something up front. So this negative 5 will cancel that positive one. That positive 8x will cancel that negative 8x. So the only thing I have left is the negative 8h. Now I'll put in my denominator, which is just an h. So my h is canceled. And all I'm left with is negative 8. Last one. So this is another difference quotient problem. It's just much more involved. Okay, remember, if your x is just an x and it's not squared or cubed or anything, this final answer is going to be whatever was hooked on to that x, because it is the slope. Okay, but we wanted to do this to get practice for when our x is squared, like this last problem. F of x is 9x squared plus 3x plus 2. Okay, so we're going to do the same thing we did on the last problem. This is just going to be more involved. Okay, so everywhere I see an x, I'm going to rewrite it as x plus h. So I'll have 9. And then instead of x, I will write x plus h squared plus 3. Replace that x with x plus h. Then bring down the plus 2. So again, this right here is exactly what this is, just instead of those x's in those spots, I have x plus h's in those spots. So that takes care of the first part. Minus your second part is in the parentheses, you write exactly what your function is. So 9x squared plus 3x plus 2. Now, if you'll remember back when we did this section last week, we saved what x plus h squared was in our notes so that we don't have to FOIL that every single time. So I'm going to write what that was. Remember, so anytime you see x plus h squared, that's what you're putting in its place. X squared plus 2xh plus h squared. So that's what I have here. So I have 9 x squared plus 2xh plus h squared. Now I'll distribute that 9 to all of these to get rid of those parentheses. So here I have 9 times x squared, 9x squared, plus 9 times 2 is 18 xh, plus 9 times h squared is 9h squared. So that took care of this part. Now to the second part where I need to distribute this 3. So I have plus 3x plus 3h from distributing the 3 to both of those. Bring down my plus 2. Now remember what the minus does when it's distributed. It's going to change all those signs. So it's going to make this a negative 9x squared, this a negative 3x, and this a negative 2, which actually helps us a lot, right? Because what happens when you distribute that negative to all of these, it makes all of these terms cancel a term up front. So this minus 2 cancels out that plus 2. The minus 3x cancels out that plus 3x. And the minus 9x squared cancels out that positive 9x squared. So let's see what we have left. We've got 18xh plus 9h squared plus 3h. So what I notice about this is they all have h's, which is going to help me cancel that bottom h. Because since they all have h's, I'm going to pull the h out, take an h out of each of these and see what's left. So if I took the h out of this, I'll just be left with 18x. Plus, if I took an h out of this middle term, it's just going to lose one of these h's. So I still have 9h. Plus, if I took the h out of the last term, I just have the 3. And here's the reason I took that h out. Because remember, the denominator of the difference quotient is h. So it cancels that. So this is your answer. What's left in those parentheses? Whew.